everyone. So today we are going to learn about the structure of glucose. We're going to learn about the linear structure of glucose and how can we draw the ring structure of glucose as well. So glucose is actually a carbohydrate, and the formula of carbohydrate is CnH2n and ON. So glucose is actually an aldehyde. It contains a functional group aldehyde in the first carbon, and then it is a hexose sugar. So since it is a hexose sugar, it contains 6 carbons. So I can say that the molecular formula of glucose would be N is equals to 6, right? So C6H12O6. So this is the molecular formula of glucose because it contains carbon 6, right? And it is a monosaccharide. That means this particular C6H12O6 is actually a single unit. So it is only one unit. Now, when we talk about the linear structure of glucose, we can see that there are 6 carbons, right? So carbon 1, 2, 3, 4, 5, and then 6. Because the molecular formula of glucose was C6H12 and then O6, right? So there are 6 carbons, we already counted. Let us count the hydrogen. It has to be 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let us count the oxygen. 1, 2, 3, 4, 5, 6. So this is the linear structure of glucose. So there is a code that I've written so that it'll help you like to remember the structure of glucose. So I've written RLR. So this code is associated with the hydroxyl group present in the glucose. So below the first carbon, the second carbon contains an OH group to the right. It contains an OH group to the left, and then it contains an OH group again to the right. So I've just given this code for the carbon 2, 3, and 4, and then 5th and 6th it's gonna remain like similar in like all the cases. So just like to remember this. So RLR. So now how does a ring structure forms? So we're going to learn about it. So for this we need to understand that this is carbon 1, this is carbon 2, we have 3, we have 4, and then at last we have 5, and then we have 6 carbon, right? So what will happen is, let us look at these 2 carbons because these 2 are the most important ones, carbon 1 and then carbon 5. Okay, so in carbon number 1, what will happen is, since oxygen is more electronegative than carbon, it will try to pull the electrons towards itself, and then when it tries to pull the electrons to itself, it's going to gain a partial negative charge. So I can write that when the oxygen tries to pull the electron towards itself, it's going to gain, I'm just going to use another color so that there is less confusion, partial negative charge, right? What about this carbon? Since the carbon also is attached to the double bond, it's going to gain a partial positive charge, right? So there is a partial negative and a partial positive charge which is developed. Now what will happen is, as we all know that this OH, this oxygen carries 2 lone pair of electrons. Why is that? For that, like, you have to know the valency of oxygen, right? Oxygen has an atomic number of 8, and then when we just like calculate it, it's gonna be 2 and 6. So 6 valence electrons are present in the outermost shell of oxygen. So it's going to make one bond, it's going to use one electron over here, and then it's going to use one electron to form the bond with hydrogen. So it's going to use 2 electrons, right, to form the bonds. But then the 4 electrons are like freely moving. So the oxygen is going to have 2 lone pair of electrons. Now I'm just gonna make it like two lone pair of electrons. Okay, so since it has 2 lone pair of electrons, there is a possibility that this oxygen will be attacking this carbon, because this has a partial positive charge which has developed. It's not going to attack any other carbon because no other carbon has double bond. Only this carbon one has double bond, and then due to which it has developed a positive charge, and oxygen has developed a negative charge. So when carbon 5 hydroxyl group tries to attack the functional group, that is the carbon 1, what will happen now is, I'm just gonna take this over here. I'm gonna take this a little bit smaller because we already understood this part. So I'm just gonna keep it over here, and then I'm gonna take this part like over here so that I can show you how does the ring structure forms. So now what will happen is, let me remove this. And then now what will happen is, so this oxygen is going to get attached to this particular carbon, right? It's going to get attached to this carbon. So I'm just going to draw this oxygen towards up so that you don't get confused. So carbon, and then it has an oxygen, right? Then what will happen is, now this oxygen I'm going to take over here. This has been like this. This hydrogen is still there, so don't get confused. The hydrogen is still there. I'm just going to take it out here. So this is the same oxygen, right? I've taken over here. So I'm just going to remove it, and then I'm going to show you how does the bond forms. So now, as you can see, the carbon 5 has formed bond with carbon number 1, right? Now what about this hydrogen? This hydrogen will also try to form bond with this oxygen, right? Why? Because this oxygen has a partial negative charge, right? It has a negative charge. Therefore, this hydrogen has a positive charge. So it will try to attack this oxygen now. It'll try to attack this oxygen, and then they are going to form bonds. Now this hydrogen will come over here, and it's going to make O. It's going to make O and then H, right? OH. So now if I count the bonds of carbon, right? If I count the bonds of carbon, what will happen is, it has 1 bond, 2, 3, 4 and 5. Do you think that carbon will be able to maintain 5 bonds? No, right? It's gonna make only 4 bonds. So this bond will break, and then only one bond will be present. So now if we count the valence bonds of carbon, it's going to be 1, 2, 3 and 4, right? So 4 bonds are being shown by the carbon. So now as you can see over here that the 5th carbon is actually attached to the 1st carbon, and then the aldehyde group is reduced to an alcohol group, right? Now let us try to draw the ring structure of this glucose. So I'm just gonna make it like a little bit smaller so that we'll be able to follow this diagram. So I'm gonna follow this diagram and let us see how does it look like. So now the structure will look like this. Now I'm just gonna draw carbon over here because all these positions are filled with carbon, right? Carbon. This is also carbon. This is also carbon. This is also carbon. This is also carbon, right? So this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and this is carbon 5. But we had 6 carbon, right? So 1 carbon is going to go above, and then it is going to be the 6th carbon. So the 6th carbon had CH2OH group attached. So this is the 6th carbon, okay? Now let us try to draw the OH and the H structures properly. So let us see in carbon number 1, we already know the carbon 1 was attached to this oxygen, and then carbon 5 was also attached to this oxygen. So as you can see over here, carbon 5 and carbon 1 is attached to this oxygen, right? So we're going to number from carbon 1. So carbon 1 has an OH group and an H group attached to it, right? So carbon 1 has OH and an H. So I'm just going to draw right now, and then I'm going to like tell you if suppose if I say this is OH and then the H, right? Because we have carbon number 1 attached to H and OH, right? So let us do carbon number 2 now. So in 2, it has an OH to the right side. So to the right side. So whenever an hydroxyl group is present in the right side, it's gonna go downwards. So it's gonna go downwards, and then if it is present in the left side, it's gonna go upwards. So that is like how the structures are drawn. So it's present in the right side, so I'm gonna draw it downwards, right? It's gonna be OH and it's gonna be H, right? Now let us see the carbon 3. So carbon 3, in carbon 3 we can see that the OH is present in the left side. That means it's going to go upward. So OH, and then H is going to go downwards, right? Because it is in the right side. Now let us see the 4th carbon. OH is present in the right side. That means it's going to go downwards. So 4th carbon, it's going to go downwards, OH, and then we have an H that is present in the left side. That means it will go upwards. In the carbon 5, we can see that there is an an oxygen which has a bond. So this is the bond, and then it has a CH2OH, which I already wrote over here, and then it has an hydrogen. So hydrogen is going to go downwards. So this is actually the ring structure of glucose. Now, there are two things that you need to remember. The name of this particular ring structure is actually known as pyranose. So we're gonna call it as pyranose. And then, as you can see, that how many atoms of carbon are present in the ring? 1, 2, 3, 4, 5, right? So there are 5 carbon attached to this ring. Although there are 6 carbons, which is like which is responsible for forming the ring structure, the linear structure, but when it comes to the ring structure, there are only 5 carbons which are involved, and then there is one oxygen atom which is involved in the formation of the ring structure, right? And then now we're going to talk about another structure, that is D or L. So it's going to be like a D or an L structure, which is actually you know like, for example, I'll just show you. For example, when we talk about the first let us see what does the alpha and beta tells, then I'll go to the D or L. So alpha or beta, so the first carbon, when we take consideration of the first carbon, as you can see, the OH is upwards. So when the OH is upwards, we are going to take it as beta. Okay, so we have to take consideration of the first carbon, which was actually the aldehyde, which was the aldehyde group, right? So if the OH is present in the upwards direction, then we call it as beta. Now if I just remove this OH and then I put OH over here and then I put an H over here, that means I'm going to call this pyranose structure as the alpha structure. So when it's present upwards, we're going to call it beta, and downwards we're gonna call it alpha. So I'm just gonna make it the old way that I did. So this particular structure was actually beta, right? This is hydrogen. This we're gonna call it beta. So now let us see the D or L position. So D or L is very important. So I'm gonna take, this is the beta one. So alpha or beta is this particular structure. This pyranose structure is actually the beta structure. So now let us see D or L. So what exactly does the D or L mean? So let us go back to our linear structure. So we're gonna take this structure is important. Okay, so if you see in the structure, the fifth carbon, like the fifth one, which is actually away from the aldehyde group, right? So we're going to talk about the fifth carbon. So fifth carbon is actually responsible for telling whether it's a L or a D position. So if the OH group is present in the right side, we're going to call it D, right? And if this OH group is present on the left side, we're going to call it L. So this is the reason why this particular glucose molecule will be termed as D-glucose, right? I'm just gonna show you. We're gonna call it as D-glucose, right? So we're gonna call it D-glucose, and then we're gonna call it beta. So if I tell you, we're gonna call it D-beta glucose, we're gonna call it that, or D-beta pyranose. Now, why did I take this particular fifth carbon? Why did I take this carbon? the thing is actually related to the chirality. So if we count the chiral carbon, how many chiral carbon are present out here? If I count the chiral carbon, this is 1, 2, 3. So double bonds are never considered in chirality. We have the second carbon, which is chiral in nature. We have the third carbon, which is also chiral in nature. We have the fourth carbon, and then we have the fifth carbon, right? So 2, 3, 4, 5 are 4 carbons which are chiral in nature. Now, if you don't know what is chirality, I request you to go back to my video of chirality and then find out what exactly chirality means. So when I talk about this one, do you think this is a chiral molecule? Because if I just draw it in a very simple manner, there's going to be H and this is going to be H, right? So this is not a chiral compound, because if we check the 4 bonds, this is different because all these structures are different from one another. This is different, but this and this are same. So we cannot consider this as the chiral carbon, right? So this is the last chiral carbon. So the reason why we are taking carbon number 5, to determine whether it's a D or an L structure, is because the last chiral carbon present in the linear structure of glucose is actually the 5th carbon. So therefore we take the chiral carbon which is farthest from the aldehyde group. So this is the reason why we take this carbon for the D or L configuration. So now I hope you understood the structure of glucose, right? And then I hope you are also clear about what exactly does a pyranose ring mean, and then what kind of molecule is a glucose. It is actually a hexose molecule, and then it contains, although it contains like 6 linear carbon structures, but then when it comes to the formation of the ring, only 5 carbons and then 1 oxygen is attached or involved in the formation of the ring. And then I hope you also understood the alpha and the beta configuration. Alpha is like the downwards and then beta is the upwards presence of the hydroxyl group in the first carbon atom. And then D or L configuration in terms of chirality, the carbon which is farthest from the functional group. So this is all about the structure of glucose, and we also have to remember the formula, this one. So every other compound will follow the same formula, except for the N numbers. That means if it's gonna be a triose, if it's gonna be a triose monosaccharide unit, then the N is gonna be 3. If it's gonna be tetra, then it's gonna be 4. If it's gonna be penta, then it's gonna be 5. So according to the name and the number of carbons, the formula is also going to change. So this is going to remain the same. Only the thing that will change is this N number. So I hope you're clear about this one. And if you like this video, please like, share, and subscribe. Thank you so much.